it's getting recorded, right?
Yeah.
No. Yeah, I can see. So our first is like smallest range one. We are given an array of integers. For each integer AI, we may choose any x which should lie between minus k to k, and we have to add it to x. After performing that process, some array will get, out of which we need to return the smallest possible difference between the max and the mean value of b. So here it's zero, no such, nothing we have to do. So this is one itself. But here if we see, if we add two, then our minimum will be 8 and maximum will be 2. So 8 minus 2, the difference will be 6. And same goes here. There could be two cases, like all, if you add 3, then all of them will be either 333 or 444. So your minimum and maximum difference both will be 0. Yeah. Yeah, any queries or approach in this?
So actually, the value what we are going to add or subtract from each and every element can be any value between minus k and plus k, right? Which is given as an input.
Yeah. Mm-hmm.
So it
X,
need
yeah.
not be the same value for all, is it?
It,
Or it has to be?
I mean, that X can be equal to, like, I mean, it can be equal to K, right? The value will take.
Yeah.
Uh,
Yeah, but if I take a value, something like
okay.
if it is between minus k and plus k, for the third example, if I take something like first I say take 2,
Okay.
so I don't have to take the same value and add it to the second, right? I can add any other value,
Yeah.
but it should be
Any
in
other,
range.
yeah, it's not.
Okay.
Exactly. Yeah, it shouldn't be like. Yeah.
Yeah, so, and the length of array is 10,000,
10,000, yeah.
value
And
same
your
and k also same. No problem with the overflow.
constraints.
Yeah.
Yeah.
Hmm.
Yeah. In code. So how will you approach? Like,
Yeah, actually, the example, what they are showing as well as the explanation in the problem, in the question,
hmm.
actually, it's a more to, move away or divert your attention, it seems to me, right? But
Yeah.
their
Hmm.
problem is very different. Because
Yeah.
if you are given an array, so what you are worried is you need to see most of the time only the difference between the largest and the lowest value has to be the minimal,
Value.
right? So one approach was like, whatever the array they give, you just sort it, and then start adding values to the lowest one in such a way that the difference between the after you do the transformation of this array, by adding and removing any of the values from this k ranges, they are the minimal. So you are more concerned with only the last means the lowest and the
Value.
maximum value, right?
Max value. Yeah.
If you just focus on those two values and then add any number in that range, k range, so then you're good.
Yeah. You want to share code?
No, it's okay. I just thinking about this.
Yeah.
So it looked to be a very different problem. It takes some time to actually understand that. But
Yeah. Exactly. Yeah.
yeah,
It's like tag is mentioned as easy, but the problem is not that clear. Like kind of.
yeah. So, but
Mm.
when you go through the examples one by one and then start realizing it, also you need to read some of the hints. But
Hints. Yeah.
eventually you understand that. So therefore, what this have stated as an easy category, it is easy problem. Yeah.
Yeah.
So one thing I don't understand is that why, if the difference comes out to be negative, it is taking the difference to be zero.
Mm,
Well, our objective is to give a value which will be always minimal. The output should
yes.
be minimal. The difference
Mm,
between the any values, all the values actually, should be the least. So if you get a zero is the best value, right? Because
both
but the
numbers are
biggest
equal.
difference. Yeah.
Mm.
No, but if we get
Negative,
something negative, then
negative means one number is very large. I mean, there is a big difference between those two numbers. That's why you're getting negative, right?
Yeah, because you're having a negative difference between the lowest
Two
and the highest,
numbers,
right?
the
So
higher,
still
higher.
you're
Mm.
deviating, whether it is a
Mm.
negative or
okay,
positive. Yeah.
They are not optimal. No.
okay, got it.
You want to share? You? Harshit, I think, right?
So I also did the same thing. I can share. Yeah.
Yeah,
Yeah,
sure.
sure.
So this is what I did. I found the maximum and the minimum in the array, and then I added. Basically, we have to close the gap between the maximum and the minimum. So next, what
Mm.
I do is I add. I mean, effectively, I subtract k from maximum max v, and I add k to the minimum, and then I take the difference. So this is what I get.
Yeah. Mm.
Basically absolute value between the difference between the two.
Yeah.
We can do math
Right.
apps
Right.
of this, or yeah.
Yeah.
But do you need to max with zero?
Uh, because I haven't taken the absolute thing. So when I get a negative number, so I would have to display zero. So that
Hmm.
it is for that only.
Okay.
Mm.
Or you can just do the math apps and it will give you the minimum.
Absolute bigger value. Minimum value, sorry.
Yeah.
Yeah.
Hmm. Yeah. So actually, you avoided doing sorting also. So it's
Yeah. But internally, it's
advantage.
also linear. Calculating mean and max order of n only it will take.
Sorting would
Oh,
take n log n.
sorting will take go for
Yeah,
n log n.
sorting
Yeah.
will take n learning. Yeah, it's better than sorting with.
Yep.
Mm.
But if I take absolute instead of maximum, comparing the maximum with zero, so I think that would return a positive value.
Yeah, I think so. What you
Absolute.
did is right. Because if
Yeah.
you do absolute value of a negative value, then
Yeah.
actually you are again giving the same results, going away
Yeah. So
from
that
the
would
zero. Yeah.
make the negative positive.
Yeah.
Yeah.
But okay.
Hmm. Yeah. This is a good implementation.
Yeah, that's very crisp. Mm.
So only the corner case, what you are doing is when the size of an array is one, then you are just returning zero. That makes
No,
sense,
when
right?
you sitting,
Because
Yeah.
because you can't do anything if it is just a size of one.
one. Yeah, in
Yeah.
that case, you won't do any.
Yeah. Hmm.
Also, if all the elements are same, then in that case also.
Zero. Yeah,
Uh,
that a small operation again. Yeah. There is the same thing what Harshit did. Like I calculated local mean and max, and just checking if your the current maximum minus the k, whatever the range they have given you, if that is equal to the same, then that means numbers are same here. Then you return zero, else you return the difference, the gap difference between those two, the min and the max.
oh, okay. So
Mm.
your max and min actually they traverse the whole array and get you the maximum value and minimum value.
Yeah, internally they are doing that. So order of n that will have.
Hmm. Okay. Oh, this is a good
So
style, I
that
guess.
information, Yeah, so that information of adding x to all the indices, I think that is of no use.
Yeah, that is what they are actually diverting our attention in the problem statement. Yeah.
Yeah.
So cleverly done that. Yeah.
Yeah, we can, or any other approach apart from this, anything, or we can proceed to next. It's a
Yeah,
lot of
because it's a
downvotes. It's
mathematical problem, right? That is what also they say in the solution. And you can't do lesser than O of n.
that's the bare minimum we can. Yeah. Yeah, let's proceed to next.
Yeah.
So it's a 2D array grid is given. Each value grid ij will represent the height of a building located there, and we are allowed to increase the height of any number of buildings by any amount, and the amount can be different for different buildings. And height zero is considered to be a building as well. At the end, the skyline, when viewed from all the four directions of the grid, that is top, left, bottom, and right, they must be same as the skyline of the original grid. A city's skyline is outer contour of rectangles which is formed by all the buildings when viewed from a distance. So what is the maximum total sum that the height of buildings can be increased? So this is the grid that they have given, and from this, when it's viewed from either top or from bottom, this is the array that you'll have for that, and by increasing the height, this is the new grid that you are getting. So and the sum total of them, like 9 for 13, sorry, 9, 13, 28. No, I think
That we have to make. We have to go for each cell.
we have to go for.
We'll have to travel the entire 2D array and find the height that each cell can be raised up to, and then add for all of them.
Yeah, actually, your grid new, whatever they given, is
Mm,
actually the value will be after transforming based on the two top down and left right what they have given here, right? Those two single dimensional arrays.
yeah.
Right.
Yeah.
If between each cell and then adding that, right? That will be the
Yeah.
result.
Yeah.
Right.
I didn't do this. Okay. 8, 7, 59, 59, 24, 26. Okay.
So if you see the grid new in the first location, earlier it was something like what was the value?
3, 3,
3,
3.
right? So if you look at the largest one in the column 0 is, and what do you say, 9, right?
Yeah,
In the yeah, and largest in the row 0 is 8.
4,
Yeah, 8.
8. Oh.
So therefore maximum you can raise that height is the minimum of those two, which will be 8. So from 3
8.
to 8 will be like the difference of 5. So they have added 5 to 3 to make it 8. And so they are actually taking that whatever the difference is to that grid new array, and then that is the result.
Minimum of what? The row and column.
Yeah, the minimum of the row and column for each and every position.
So why we are doing the minimum of row and column?
Because that is the maximum you can raise that building height.
Oh, okay, okay.
Because you don't want to actually, spoil the skyline.
Yeah, got it. Yeah,
Yeah.
couldn't get that.
Frankly, the solution itself is given in the example. Don't you feel that?
Yeah, yeah.
I did.
Yeah. That is what the implementation is.
This I couldn't visualize this one like.
You know what they did in the grid? Yeah, whatever the grid
Yeah,
is, dimensional array.
yeah.
You understood, right?
Mm.
The skyline viewed from top or bottom, that line, a skyline viewed from left or right. So these two-dimensional single dimensional arrays are nothing but whatever is the minimum, whatever is the maximum in the column and what are the maximum for the rows. So that is what is collected here, and using these two single dimensional arrays, they have created this grid new, which is like you add the height to each and every building, so it reaches the minimum of these two values of these horizontal and top down and the right left or right,
Yeah.
and then whatever you are in the difference, what you are actually adding to each and every cell in the grid to make it grid new. So that if you add that all those values, then you return that value, which is 35. That is your output.
But I couldn't get it from the question that how the solution is, because I couldn't think of this. I got this top and bottom, but getting the minimum of the two, I didn't occur to me. How did you find out from this question?
Because if you look at the grid new, if you look at why he made it to 8 and not to 9. So the reason was like if he had made it to 8, then in the row side it would have spoiled.
From
right?
these solution, right? Like we can see that is happening. But if we don't have this grid new and just the grid is given, how to come up with this?
Oh yeah, so you mean to say, yeah, the reason is one thing is very clear from the problem statement that you don't have to spoil the skyline, correct? So what is the best you can do? So whenever you are adding a building height, you should not add any height which is greater than the row greatest or column greatest.
Okay.
So that is the only trick there, yeah.
Yeah, okay, got it.
But they have given the example, the example clearly, whatever they have written is exactly the implementation.
True.
So they should not have given this example, maybe just give the value 35. At least the two lines, top to bottom or left to right, it was not required.
But the last one is not the 7 and 3?
7 and 3, So if you look for 7, what is 7? 7
minimum
is
of
the
7
column.
and 8. Okay, minimum of 7 and 8.
No, 3 7s. Top to bottom, the maximum is 7, right?
But the value is 7 here. If we are taking that minimum of the two, minimum of what?
Minimum of, you have to take that row and that column. So if you take the last column, the maximum will be 7 and minimum will be 3 in that last row. Last row, all threes are there, right?
Yeah. Okay. I was talking about the 0 and 3. So that will be minimum of 7 and 8, right?
Okay.
0 and 3 value. The row 0 and column 3.
Row 0 and column 3. That is 8, no?
Row 0 is 8 and column 3. Column, how you are making
7.
this? No, if you take row 3, you have to take column 3, right?
So what are you, is the grid or the grid new? What are you looking
I'm
at?
talking about the grid new. The value is given 7 for cell 0, 3.
Oh, 0, okay, yeah, 0, 3, 7. Yeah, because, in that case, what is 7? 7 is the maximum value of the column, correct?
Fourth column, yeah. Third column, whatever, yeah.
Yeah. So that is the maximum value.
And minimum is the row, last row.
And we have to take the minimum of 7 and 8, right? That's
7
why we are
and 8.
getting 7.
Yeah. 7 and 8.
Okay,
Correct.
that is what I was asking.
Yeah.
Okay, thank you.
Yeah, if somebody has implemented, like.
I can show.
So what if the value are equal? So let's say we have on the left side we have 7. Let's say on row, the second row, right? Left side we have 7. On the right side we also have 7. So we look on the left view, that would be 4730, right? On the right view is also 3790.
So can you give a specific example, like which one you want to pick up in the grid, which column and cell?
Okay, look at the new. Let's look at the new grid, right?
Uh-huh.
New one. We look on the left on the second row.
Uh-huh.
Right? The first we see the first seven, right?
Okay.
And then we also see the last seven. When we
Yeah.
look on the left view, we see seven. You know, on the right view, we also see seven. But this seven is not the same as the other seven. You know what I'm saying? The position of the
So
position
each,
of that value on the left view is not the same as the right view. I guess it not affect the answer, but you know, something that
so if you look at, you are saying like if you look the value, or so if you look the skyline from left and right, that is what you are trying to say, right?
yeah, the left and right.
They don't appear to be the same.
Yeah, but the
So, you know, when you are looking at from the left and right, you have to look for the whole of array. Okay. So, like if you see from the left, for example, in the grid new, the first building will be 8, right? And the second will be 7, and third will be 9, correct? And the fourth will be 3. So, if you go to right, again you see from the right, the biggest will be again 8 in the row 1, right?
yeah.
And then it will be 7 in the second row, and third will be 9,
My
correct?
my point is on the second row, seven. This seven is not the same as the seven, you know, on the left.
Yeah, that is fine. The purpose is only to have the values of the heights. They should be same wherever you look from, whether it is right or left. So it doesn't matter which building it is.
Okay. Yeah. Then yeah, it shouldn't affect the answer.
Yeah. Yeah, I think Harshit wants to share
Yeah.
the solution, right? Yeah.
Yeah, so it's exactly what you explained. I found the maximum for each of those rows. Am I audible?
Yeah.
So I found maximum for each of those rows. That is in 990, and I found the maximum for each of those columns, and I stored these in two different arrays. Now I traversed this 2D matrix, and I found the minimum of uh, the maximum of that row and the maximum of that column to which that cell belongs, and subtracted that with the value in the grid. And I cumulatively kept on adding this to the sum variable.
Good. Yeah. I don't think we can do any more optimization in the solution, right? That is the maximum you can optimize it.
Yeah, maybe we can save some space, but I don't think so. That is possible.
Not possible, right?
Yeah.
So
Yeah.
what will be the time complexity and the space complexity?
So time complexity. So it would be uh, the first the first loop from line 14 to line 21 is O of the number of rows. Uh, from line 23 to 30 is O of number of columns, and in the last loop it's O of m into n. So it's O of m into n only.
Hmm. So if m and n are same, it will be n square then.
Yeah.
Hmm.
Sorry, it's O of m into n for all the three loops.
Yeah, so big of n, yeah, n square,
Right.
big of n square.
We can move on.
Yeah, okay. Thank you.
We can go for next then. So here, array of numbers, you have to find the duplicate number. An array of numbers containing n plus integers is given where each of the integer lies between 1 to n. We need to prove at least one duplicate number exists and assume there is only one duplicate number. Find the duplicate one. In the first case, you can see 2 is your duplicate. And here 3, and you must not modify the array. Should be done in order of 1, otherwise problem is very easy, I think. And runtime complexity should be less than O of n square and only one duplicate number in the array, but it could repeat more than once. Yeah. So any queries here?
So to find a duplicate number, I think it should be very easy if you do a sorting, correct?
Yeah.
That's the easiest way to do it. So
Right.
Yeah.
With sum, is it not possible to solve?
I'm sorry.
Pardon?
With sum. So the array length is n plus 1. So the max number can be length minus 1. And 1 to length minus sum is length minus 1 into length by 2.
It is not in sequence. Number is not in the sequence. It is in between that range, but the number is not in.
All are not there. Okay.
It's not there.
Okay.
It's not in the
It can be done by cyclic sort, right? I mean, placing all the elements at the right position, and which is not present at the right position would be duplicated at the end.
Yeah, that's also kind of one approach.
No. Actually,
What
I
is
mean, the
it?
complexity would be n at that point.
all numbers are there, right?
No, there it's not only one repeating you can have. It is at least one repeating. There could be multiple repeating. Yeah.
This is the problem. What they're saying.
How can we do the cyclic sort? I didn't get that part.
I mean,
according to
placing, yeah, just swapping the position at the right. If one is not at the right position, and then swap
Then you
it
have to
with the other.
traverse the.
Yeah, actually traverse the whole area.
Yeah, insertion sort, right? Something like that.
Yes,
but they
something like
say
that. But
that
we have to.
you must not modify the array.
Oh, okay.
That is one constraint.
Yeah, exactly.
Is there a constraint on the size of the array? No.
Yeah, size definitely. Otherwise, there is nothing in the problem. I mean, if they don't give any constraint on. Oh no,
So
sorry,
we cannot
size.
use extra space.
Sorry,
Only
I
one
thought
extra space.
Array length.
that is yeah.
But frankly, the problem is very easy if we didn't have these constraints, right? So
Yeah.
There is nothing in the problem.
right, yeah. So he also said, right, if you add all those numbers and then do like a counting sort, just add a 1 to n, you should be able to get that number. But for that, they are saying you cannot actually assume that it's going to be only single duplicate. There might be multiple duplicates of the same
Multiple.
number.
Yeah.
So if you go look for, if you can't, if you do sorting, you cannot do it because you are consuming more
Modifying
space. Yeah, also modifying the array.
Really modifying also. All the possibilities they have closed.
Yeah.
Like in whichever field area you can think. You know.
But even if you use something like a set or maybe hash map or so,
Then it will take the
But
space,
hash
right?
map space is there, no?
yeah, but the problem gets accepted by Elite Coda. But the only
yeah.
problem is we have to do it as per the notes. So
Okay.
only that is more challenging.
I think this one can be solved using what I call the pigeon hole principle. Because we use by using the index of the array, we leverage on that as a pigeonhole. So if we see the duplicate element, then we mark that value as a negative.
Yeah, correct.
And
That
then
is
because
also
they don't want us to modify the value of the array, so at the end we run through that again, and if it's negative, and we change it to become positive.
in one pass also you can do.
Oh,
But
okay.
we are changing the array, right? That array is only read only.
Yeah, but if you change internally, and then at the end you restore the value of the array, would that still
No,
consider be
I
changing?
think we are changing it. I mean, we are changing and reverting back. It means we are changing it.
I didn't get that. Can you please repeat?
It's like
What is-
It might pass in the lead code, but if you look at the notes, what Sumit is saying is right. You need to assume that it's read only. So
And one thing, so we were looking into the addition. I mean, adding all the numbers, then maybe dividing it by the expected output. I mean, why didn't we follow that approach? If we add all the numbers.
So
more
if
than
you look
2
at
to
the node
we are
number 4, node number 4, they say that if there are more than one duplicate, but the array size is constant, like n plus 1. So you'll be missing one of the number.
Okay.
So then you won't get the right number. So there might be a test
Would be
case.
multiple of something. Okay.
Yeah.
So that sequence n plus 1 divided by 2 works for the arithmetic sequence.
Right. It works, correct.
But there is only one number which can be duplicated, right?
No, more than one.
No, more than
No,
it's written.
the same number can be more than one time.
Same number would be duplicated. Yeah, there is only one number which would be repeated.
But it could be repeated more than once.
Yeah.
Yes.
You can have all the 4 values with 2 as 2.
Yeah.
So then there will be a problem.
Can we do something? I mean, we know that. I mean, the sum of 1 to n number is in with the formula, and then if we just XOR all the number.
If you XOR, so XOR of only even numbers is 0. But if some odd number comes, then you will have the number in that case. Like XOR of 2 XOR 2 will be 0. Again, one extra 2 comes, 3 2 comes, then the result will be 2 again.
Yeah. So what I'm saying that if we actually get the sum by iterating the array and get the sum using the formula.
Which formula?
N into n plus 1 by 2.
Oh,
order. For that, you have to have the arithmetic sequence, right? I don't think it's given an arithmetic sequence.
Yeah, sequence is not given, no. Like
it's 1 to 1. It says that 1 to n plus 1.
Yeah.
The value is in between those range, but it is not in like 1 2 3 4 or 1 2 1 3 5, something like that. It's in that range.
Oh, that's why it says that, I mean, 1 to n plus 1.
In between, but not in the
right
value. Because I tried that and it didn't work because I had the values and it was, for some test cases, it was 7 and 18 and something like that. So unless if we have in the sequence.
No. If you see that each number is between.
No. See, if you have a value of 4 as n as 4, so you will have an array size of 5. So in that you can have 1, 2, 2, 2, 2, 2.
Right.
You can have a single 1 and 4 2s. That is valid test case. So in that case, your XOR operation will also fail, right?
XOR operation will be 1 in that case.
So because here all the tricks won't work, but actually the sorting could be fine, as well as the hash table, that also will be okay. But they, as per the notes, actually it won't. It's not the right way to do it. So you have to think very differently to actually solve this problem.
One I used what Leon mentioned, but I don't know if it also doesn't suffice. It's like indexing method, putting a -1. It's like
what is that? Can you explain that?
Yeah.
Can you run it and see?
Then you are mutating the array, right? It is read only.
Right. Yeah. He's doing that.
That's the. And second, what I saw there, no. Yeah, this is what I was saying. I have done. Okay, I'll tell you. So our array is like, but we are not supposed to, what is said, play with the array, right? What it was 1?
Oh, the first one, it is 13422.
Yeah, 134
22.
22. So this is 0, 1, 2, 3, 4. So when you go here, you go to the first, I mean, go to the index of that and put a minus. Next time when you go to the third index, 3, whatever number you see, take the absolute value of it and put a minus to the element where you see. Again to the 4, you go, you put a minus. Now you'll go to the 2, you'll put a minus over here. So second time again you go to 2, you are again hitting the same place. That shows that a number is repeated
That
over
is
there.
cycle, something like cycle detection. This is the same
Exactly.
thing? Oh.
No, no, this is not a cycle detection. He's actually
That is Floyd.
modifying that array. So,
Yeah,
but
it's a index.
yeah. But can you run this and it still passes in the lead code?
Yeah, it's passing.
Sorry, I lost you. If you could repeat that again.
Sure, sure. See,
Yeah.
first index is there. I'll go to index 1. I'll take 1 and go to the index 1 and put the minus to the element which I've already, if I have seen. First time if I see, I put a minus. Next time I'll take absolute value of this, that is 3. I'll go to third index and put a minus. Again, next I'll go 4. I'll go fourth index and put a minus. And again, when you go to 2, I'll put a minus here. And next time when again I see, I'll again go to the same index and I see that already there is a minus, so which clearly shows that I have already seen this element earlier.
Yeah.
Okay. Then you toggle that back to 4.
Yeah, he will
No, I don't.
actually make it to positive numbers.
But
Yeah, I'll
then,
make it.
but then how do you know? Oh, then you know that you're coming from. But
Same
here,
position.
two
Hitting the
times you
same
came to the index
same
2.
place.
So you know that 2 must be repeating. But if
Exactly. Yeah.
2 repeats 3 times, then
So
you
then again, you will hit the same place. No. So that also shows that there
no
is
no.
some number which is repeating.
What I'm saying is here the negative, the toggle from negative to positive, that basically triggered that I must have come to this place before.
No, actually, once you make it negative, you don't do anything. You just keep it negative. N number of times you come, you keep the same way.
And
No,
then
no, we
we
have to
toggle
make
at
it
the end.
positive for going to the next element. Yeah, you
No,
don't do anything there, but take outside and make it positive. You don't do anything in there.
when you actually just take an absolute value and then run it for the index.
Okay, yeah,
Yeah.
that is what.
But once you modify that, make it negative, it means you have visited. And that is
It's
what
done.
is like a hash table, what you use, right? Instead of using a hash table, you are using the same array.
Same, yeah.
So we can apply this for all, finding all the duplicate element, right?
Yeah.
No, I don't think it would work for multiple duplicates.
Well, it
Pardon?
should, right?
It's
Oh, you
working.
mean to say many number of duplicates? Many
Right.
numbers having duplicates?
Yeah,
Why
yeah.
should not be possible? Because it is like a hash table again, right? You can find out really later on. Scan the whole array and see.
Yeah.
It should be possible.
And another approach is they have used cycle detection, that Freud Warsaw in linked list to find a cycle.
Yeah.
Yeah, that
Isn't it the
one
same
is.
thing? Like we are following the same thing, right?
No. He's actually modifying that array. But
Yeah.
even
Oh, in the, okay.
yeah. So the solution also says that it's not intuitive. You can't come to the solution, and that is the only way you can solve this based on what the nodes are given.
Yeah.
But if I think Shashank is going to explain. When Shashank actually explains it, we all know that is the famous algorithm we have been using also. If you do
Yeah.
for a linked list, right? If you have a cycle in a linked list, how do we identify? That is the exact way we have to do for this one. But it's here,
Same thing, yeah.
it's only the array.
Yeah.
It's slightly interesting, but once
Again,
he
out of
explains, it will be very easy for everyone actually.
to follow.
Yeah. That's Shashank, go ahead.
Yeah. Like, so cycle, I mean, in that linked list, what we have? It's like we have two pointer, right? Fast pointer and slow pointer, isn't it? Uh, let's say this is a linked list. What we do at some point of time, let's say this, and this got connected to this. we keep one pointer, one will have the fast pointer, the other will have a slow pointer, and both will be running like what you say, in the step of 1:2. Initially both are at this position. You move your slow pointer by a step of 2 and fast pointer by a step of 1. So if there is a cycle somewhere, this fast pointer and slow pointer, they'll meet at some point in the cycle. So that is the place where you find that a duplicate
But we
exists.
do the same thing in this, right? We go to that index, what value we have.
Yeah, see, first there are two things. One is, in one pass, you need to find where they intersect. Okay.
Intersect, yeah.
Yeah, and once they intersect, from there you again start one pointer, and another pointer you start from the starting of the linked list. And so where you see the place where actually it enters the cycle is the duplicate number.
Yeah, that I got it. But when we are traversing the array, right? How are we traversing each element we are going, or we are going to the index?
We are actually taking the index as well as the values.
Okay, anyone has the code to share for this method?
I saw here discussion.
I think that might help.
Shashank, one thing I have to ask.
Yeah.
So, was there any logic to start at the same place? Like you've start slow and fast from the same starting index. So what if I start slow from the 0th index and fast from so let's say two places further? So would that make any difference?
Oh, the two places like in the ratio of 1:2, right?
So I'm giving a initial offset, initial separation.
Yeah, so slow pointer will be here and fast pointer you are saying somewhere two places ahead of slow.
Yeah, on the third node, let's say.
I think that will work. It doesn't make difference.
There is an equation actually for that, I mean, which suffices the proof. So if you see, I think.
Because when we go in the loop and slow and fast again becomes the same thing, right? It just starting ahead won't make a difference in that cycle detection thing. That is what my understanding is.
So I also thought the same, but it doesn't work that way. Because the logic is that they have to stop at such a point that if if I set slow to the initial and I move the fast from that intersection point, they have to reach the starting of the loop.
Yeah, that is the second step. In the first step, you can start from anywhere.
Right. So if I start with some offset, like some initial separation, then they do not always meet at a point where I can, get to the starting point.
Yeah, makes sense. Yeah, because it will meet at the next position instead of what we are supposed to meet.
It might take more loop, but it should meet at the same position even if we start.
Yeah, that's true. It will take more number of loops, but it will meet.
Yeah,
it will meet.
It will meet, yeah, but you won't be able to find the intersection or the entry point.
Intersection is the second step, right? After we find the start node,
right?
Then we do.
Let me share it. I think I had.
Yeah, I don't know, but yeah, we'll have to try that.
So I tried that. So basically, we have to start from the same position. It doesn't work if we give separation.
Oh, really? Let me try to.
Yeah.
I'll show you that equation. Let me check.
Okay, you're sharing the code, right?
Yeah. I'm just searching where I saw it.
You can share it on the Discord later, and I can take a look.
No, I'll share it now only. It's not.
Oh, okay.
Are you trying to show like the hypothesis?
Yeah, exactly. This one.
If you want, I can share. I have the hypothesis with me.
Yeah, sure, share it. I was talking about this equation only. Okay, yeah, share it. That suffices that where, I mean, at what condition will it meet? Yeah, go ahead.
Okay.
Shashank, I have a question.
Yeah, sure.
In that, in this finding a duplicate number, like if you had 3 2s, but there was a 2 at the fifth index, then we wouldn't be visiting there, right?
The one which I mentioned, that index based method.
Yeah.
So what you are saying in that case?
Like if you had 3 2s instead of like 2 2s, so then
Yeah.
at the fifth index would be the third 2. So we wouldn't be visiting that 2, right?
Yeah, I won't. Yeah, because that's the fourth index. At max 4 only I'll go. Fifth index I won't get.
But it doesn't matter because we just have to find, like, even if we get one duplicate, so we can
That's
look at
fine. Yeah, answer. Yeah, yeah, makes sense.
okay. Yeah,
Yeah,
thanks.
thanks.
So you can see my screen.
Yeah.
So I always get confused with this. So I created a screenshot to remember myself.
Yeah.
So basically what we are doing, slow will move like this. At some point, it will be here. But by the time fast will be doing one cycle this, it moved y, x, and again y. So then they meet here. So the distance covered by fast would be x, y, x, and again y when it meets here. But by the time, if slow would be move the distance k and y. So basically, slow moved k plus y, fast moved k plus y plus x plus y. And we know like fast is 2 times of slow.
Okay.
Then putting, so basically fast is always move twice the distance of slow. So if I put multiply slow distance by 2 and have this equation k plus 2y, which came from here only, and
Yeah.
slow is equal to 2 plus 2y, and if you do simple mathematics, 2y will get cancelled and k become equal to x. So basically, if I do the same thing again and move k steps, and from where I meet last time, and again move k steps, I will meet the position where the intersection actually started. Does that
Yeah,
make
good,
sense?
very good explanation.
Yeah, looks very easy now. Yeah.
Yeah, this
But
is the
again,
equation I was searching for. So what Harshit was saying, that if I take an offset, he is telling that it won't meet. It should work. No, fast is equal to 2 times slow. So
no,
if
but
I keep my pointer at
they have to start where they have intersected. No, sorry, where they have meet. Where we have told like, okay, there is a cycle. From that point only they have to start. So it will move k and it will move. So if you move this by k places, then you will meet the place where it is intersected.
But in the first
No,
step,
but
we can start from any position. That was the
yeah, that is what I'm
vision.
saying, because fast is equal to 2 times slow, so I can use that offset and then move like one pointer at fast, the other at 2 point ahead. Slow I'll keep, or
So
I mean fast I'll keep 2 point ahead and slow I'll keep at the beginning.
So I think you can start from any position, but when you meet, you have to again move case steps from that position where you have started for the first time.
Yes, yeah, that is what. Yeah.
No, I
Okay.
think when you offset your fast pointer initial, but
Hmm.
then your meeting point would move ahead.
Yeah, but
Right?
it will meet. Yeah,
Yeah, it
meet.
will meet, but it will move to some points. At least you can find a cycle. Okay.
Mhm.
But when
Yeah.
you want to find the entry point of the loop, you can't find it.
Yes.
right.
So I think first operation could not find the entry point. That's what that linked list to
Correct.
algorithms, where it can first it only tell like there is a cycle, and after that it finds where the cycle started.
So yeah, for that thing they have used the same starting point.
Yeah.
Yeah. Okay, that makes sense. Yeah.
So you can start from anywhere, but when you're doing this k steps from here and k steps from here, then you have to take that point where you have started for the first time, where you actually started your slow and fast.
Yeah.
Yeah, that makes sense.
Yeah, that's good now.
Just to add one thing to this explanation, so I was asked once in an interview that why do we set the speed as twice?
Mm,
So that is also a hypothesis, and
yeah,
Yeah,
it's
so
that you can easily show using some example. Like, hey, if there is a cycle, they will meet for sure. if I have to do that?
There is no reason for that. Based on the proof, we are. That's why it's called hypothesis, right? Based on the proof, we are saying, if we start at fast and slow 2 times of that, it will meet. We don't have any intuition for that.
No,
I
but
think meeting can be done without any difference, like not only double, but finding the entry of the
Joint.
cycle, we need the fast and slow double, right?
No, the thing is that if there's a cycle and we are setting the speed as twice, then for sure these two pointers would meet. If we set the speed as something else, then it is like sometimes they might meet and sometimes they might not. So the reason for this is that the speed is for let's say the speed
Faster.
for fast is twice. So at every step, the distance between these two nodes is increasing by 1, right? So there would be a point when the distance between them turns out to be n. So n is the length of the loop. So that is when these two would meet. So for example, if the speed is thrice, then the distance would increase by 2 steps. 1, then 3, then 5, then 7, then 9, then 11. So it is not for sure that these two would meet because the distance is not increasing linearly.
Yeah, but
So
if
we
you
can
take it
use
even increase, like 2, 4, 6, 8, then it might be meet. But if you take odd, then you might end up in a parallel situation or an infinite situation.
No, basically, they meet when the distance between them is n, like the length. So it is possible that if we taking even, then 4, 8, 12, 16. So if the length of the loop is 10, then in that case, that would be missed.
Yeah, but you'll have to do it for more number of iterations.
Number of loops will be more, like iterating the
Because if it is
cycle.
a cycle, somewhere you have to meet, if it's an even number. If it's an odd, then I agree.
Okay, yeah, they can meet later on, yeah.
Yeah, it will take some time, but they will meet on. But twice is the optimum one. It is the best solution.
Yeah, they'll meet the earliest. Yeah.
So I can use 3 also, right? Fast is equal to 3 times slow.
But then in some cases, it might not, based on the length of the loop. They will keep on having a difference of 1 always.
Okay.
I think that would have to, some mathematics related to prime factorization is in play here.
Or I think you can make any number, any positive number using ones and twos, but not with ones and threes. For example, number 5. You can make it with ones and twos, but you cannot make it with ones and threes.
For pardon, could you?
So I was saying you can converge at the cycle at the common intersection point using ones and twos because you can make any number on a positive natural number using ones and twos. So, but not with the 1 and 3 because you will be missing 5. And similarly for all other things.
Very good point.
Yeah.
Nice observation.
Yeah. I think Rajendra is also saying the same thing, right, Rajendra?
Yeah.
So there is a proof for that, or like from observation, it is coming, like any theorem or anything like that.
I think Anup just, it was a personal observation since, yeah.
Oh, okay. Yeah, that makes sense. Yeah, code was code is simple. I found here itself. So this is what I mean. To the initially number, to the number itself, they are what you say, initializing both the slow and fast pointer, and this is always true while one, and just slow they are initializing to this, and to the fast what they have done, they have first taken that number and went to that index, right? First number what was 3 was 1 was their node, so nums of 1 and, what was the first number? Let me see.
So They are
Index of
moving by
index.
the index basically. Whatever is the value, they are making that as an index.
Yeah. So in the slow pointer, you are having the number 0, whatever is that value. Then you are going to the, you're using that as an index and going to that value.
Okay.
Then we are not following that 1 and 2 option, right? Because fast is moving at a different speed.
No, it is twice, right here. Nums of nums, fast. So
This is
therefore,
what, yeah, nums of
yeah,
nums means what?
it is going twice.
Initially you were at 1. So nums of so 1 it will take, it will go to 3, right? It will be 3, no, nums of fast. Initially it was nums of 1. Nums of 1 is what? Nums of 1 is 3. So nums of 3 it will go. So 0, 1, 2, 3. Yeah, it will go to 2. This fast will be initialized to this 2 only, right? Because initially nums of 0 it was there. If
Yeah,
we
and
see
the slow
here
will be at 3 point.
at
3.
yeah, slow will be here at 3. Yeah. And yeah, as long as you don't meet, just keep on doing that. Slow update with this and fast to the previous. Yeah.
Okay. I have a slight different variation what I did because I think your Python version is good. It's very, you have combined everything in one,
Yes.
and that's the best one. But in C++, actually,
Yeah.
I have separated. So I'll just share that, quickly.
Yeah. Sure. Sure.
Yeah. So it's exactly the same, but slightly doing it, in two ways, taking more time to do that. But actually, I
Yeah.
understood this well. So what I did is I'm using these two pointers, P1, P2. One is a fast pointer I'm saying, and this P2 is the slow pointer. And the fast pointer, I'm actually setting these indexes to 0, 0. And then for the P1, I'm just doing the same. Nums is equal to nums of P1 and the slow pointer nums of P2. And then I'm doing a do while loop. Okay. And I'm just doing it till P1 is not equal to P2. And on line 13 and 14, I'm actually first checking if there are no cycles. Okay. If there are no cycles, then returning -1.
So how this gives the no cycle? P1 is equal to n?
Yeah, because if P1 is equal to P2, right? So if P1 goes to value of nums of size, because at least it has to be equal to P2, but if it goes to the end
the
of the,
whole,
yeah,
okay.
so then I say there is no cycle. But then I come here and then I can set the way we talk about that linked list cycle, right? We start with P0, P1 as a 0th index again, okay, because we are not going to disturb what that P2 value, P2 index is, but just change that P1 to 0 and then again do this while loop. And at this time, I just increment by 1, 1 index, sorry, 1, 1, what you say, node. And then when they are not equal, they keep on going inside this, but when they're equal, then come and return this value P1. Okay, so this is the exact implementation what I did for the linked list, but I just wanted to show it is done in two paths,
I missed how you checked for no cycle thing.
No cycle, if you keep on going, so either you will, what you say, when you reach end of the array, okay, that will be nums of size, right? That will be n.
But why do you think you will go to the end of the array?
So if it is, if you are not able to come out, right?
If there's
if
no
there is no
duplicate,
cycle.
then it will go reach till the end. P1 will reach to the
So
end and you
it
won't
has to
find that
reach
condition.
that, right?
But that is driven by what is the content of the array, right?
Yeah. That's why if there is no duplicate, then you'll never reach. If there is a duplicate, you will.
Yeah.
How? Okay, maybe I'm missing it. That's fine.
Yeah,
And we have to.
actually I just did this. So yeah, what you say, I didn't try with the test case like that. Yeah, I need to try that also, but maybe there is no test case like that, therefore it passed in the lead code also. Yeah. So I think in the
But in this
while
case,
loop also I should have some condition saying if P1 is equal to is not equal to n. Yeah, there should be some check. Then only actually we should work. Yeah. But anyway, with this also it worked. So maybe they are not actually having a test case like that.
yeah, but in this case, there would always be a cycle.
Sorry.
In this situation, there would always be a cycle because it says that the range of the numbers is between 1 to n. So there would be at least one repetition, and the size is n plus 1.
Yeah, therefore it is actually skipping this. The 13 or 14. Yeah, makes sense.
But like the how many operations will be there on line number 8 in this do while loop? Like total, what is the complexity for this do while loop?
Complexity for the do the first one.
Yes, for the first one, line number 8.
Order of n only it will be.
So it has to be the way he explained, right? Asim. So it depends on where they meet, right? So if your cycle is smaller than your initial that k, so then it might take more than O of n also, right?
Yeah, but it will be
So
always
order of k into n it will be. Okay, go ahead.
it will be more than n, but it will be bounded by 2n.
Yeah.
Because the flow pointer is never doing making a full round. I mean, the slow pointer is never making more than one cycle. So it will always be bounded by 2n.
K plus 2n something, yeah.
I am not sure about that, but it's okay.
K plus 2y. Yeah.
Is there any proof that slow pointer doesn't do more than one? I mean, it doesn't enter into the loop again.
So I think if we say that initially there's some separation between the slow and the fast pointer when they are in the loop, now that separation keeps on increasing by 1 unit every time. And when the separation is n, they would meet. So this I think proves that slow would not make more than one round. Where n is the length of the loop.
Oh. But
yeah, you can't have the test case. Sorry, go ahead. Yeah, I was just checking the test case. Yeah.
Yeah, I think that makes sense what Harshit was saying.
A difference of n units is same as being coincident. Although the distance traveled would be different, but if the separation is n, then I think that is where they meet. Yeah, so I think this proves.
Makes sense, yeah.
Yeah.
No. I mean, every time the length is increasing, but it is moving towards, right?
Towards the joint you are saying. I mean, the point where the cycle starts.
No. I'm saying if they're in the same loop, they are moving towards. So I'm not sure actually whether it will move that n length and increasing one. I'm not yet. Sorry, I'm a bit confused actually.
So
Yeah, that
what part was confusing? Like I didn't follow
So
that.
is there any proof that the slow pointer um, mm, doesn't enter the loop more than once? I mean, the 2x plus the k plus 2x and
Yeah,
beta.
so slow pointer won't enter more than once, right? So because if it enters, then it means it has to meet the fast pointer, because the fast pointer actually, whatever the distance slow pointer has traveled in the loop, right? So the fast pointer would have traveled twice in the loop, right? So it has to meet.
But
I mean,
it is only one
it has
loop, or
skipped,
it
right?
might go more. That is my
Yeah,
concern.
it might go more also. It depends on what the loop
It
size
might.
is, right?
Okay.
Yeah,
Okay.
it might, I think.
Yeah, k plus. I mean, it might have got skipped as well. I'm trying to say that.
No,
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 but
it
by
won't
that
skip. No.
time,
At every step, the distance is increasing by just 1 unit. So inevitably, we'll at some point of time we'll have the separation to be n.
Well, I'm trying to say that if even if it is move, so the fast pointer is moving by two distance, right?
Right.
yeah,
So if it is an odd and even, it might have got. I mean, I was trying to look in that point.
So what is odd and even?
I mean, the odd index and even index kind of.
odd even. I mean, the ratio you are telling or something.
No, I think he's saying the cycle size might be
Then,
odd or even
oh,
based on that.
yeah, that can affect. But I think by the
That's
moment,
why I was asking. I'm not
It
sure. I didn't. I'm not yet convinced on whether it can or it cannot enter the loop one more time.
it
because
might take more than one traversal of the loop. That is my understanding. Is
Then, but it,
right. What others is, or it is for sure that in first traversal it will meet. I will revisit because that is what my understanding was.
I think they'll meet in the first one only.
But the
I
thing
mean,
is,
before.
by
but
the
that is not such an important point, right? The thing is, whenever it meets, if the fast pointer is running twice the slow, so that will be the optimum. If it
Yeah,
with
yeah,
more
that is
than 10
there.
times
Yeah,
also, it doesn't matter, because that is what it has to run to
just
find
for the
the cycle, right?
understanding, I think.
Yeah, and that will be the
Yeah.
most optimum position, I would say, or the time complexity.
yeah, yeah, most optimum one.
Right.
But assuming that n is 10 and we loop 10 times, then we are at n square, right?
there is a
Yeah. Never thought that
if
way,
your
but
slow
yeah.
pointer will be an
Because this cycle finding itself takes some time to, at least the hypothesis part. If someone is going to ask a hypothesis, the way Asim explained is now it's very clear. But if you have other variations of it, it becomes more complex. And just understanding the hypothesis and just putting that in somewhere and saying, okay, this is what the hypothesis to explain in an interview, that I think is still enough. But if you have many variations to that, that will be more complex, and it's very difficult for even the interviewer to actually conclude that, I would say, unless we
yeah
actually do a lot of
research
test
in this.
cases
Yeah.
and all that. Yeah.
So what they are telling that slow pointer should not have traveled the loop more than once for greater efficiency. If, and I'll share this one. I don't know. They're asking like
I've
why
shared
can't
a
they take
video.
this range of 3, 4, and 5? Mhm.
if it is more than 2, then it will take more loops. So optimum is 2, basically. That is what.
Yeah. That is what it looks like it is, but if we read more things, I think we might get more confused also. But yeah, surely we need to have a very clear understanding of what things are. Yeah. Now at least it is very clear how to find a cycle and how to meet that point. Okay, and if there is an offset in running with the P1 and P2, as Harshit was saying, then there might be not a proper place to find that entry point also. Or maybe it might not be optimal.
Work right.
Yeah, yeah. So if someone confuses you in an interview, at least 2-3 things are clear now. And if we get a similar problem going down the line, we'll again go through more things about variations about this problem.
Yeah.
Yeah, there is a good decision. Yeah.